Arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. So we are still going to have to use our knowledge of arithmetic and geometric sequences in this next part of the unit, but now we'll be looking for the sum of those sequences. So as an example, we see this series right here, 5 plus 8 plus 11 plus 14 plus ... So the difference here is from before, we're not separated by commas, we're actually adding up all of these terms to make it a series. Now, if we said that the series would end right at that point, we would say that the sum of the first four terms, so we use a capital S for sum of the first four terms, that's our n value, would be equal to 38. Now, if that were to continue, so plus ... if this pattern were to continue, and this is a arithmetic sequence of numbers because we're adding 3, adding 3, adding 3 as we go, we could then figure out, if we knew some sort of formula, what the sum of the first 20 terms was, or sum of the first 100 terms. So for that, we're going to need some sort of general formula. So what I'm going to do to come up with the general formula, I've written in general what the sum of the first n terms would look like. So remember our a value is term number 1. And in order to get term number 2, I would have to add d to that, add the common difference. So that's term 2. And then to get term 3, I would have to add the common difference again. So it'd be plus 2d. So that's term 3, and so on, so on, so on. We keep adding that up until we get to term number n. So for the sum of the first n terms, we finish at term number n. Now, the second line that I have here is actually the exact same thing, but just written in the reverse order. So instead of finishing with term n, I'm starting with term number n. Now, to get to the term previous to that, so this would be term n minus 1, we're going in the opposite direction, so we would be subtracting d. To get term n minus 2, so two terms previous, we'd be subtracting 2d. And then so on and so on until you finish off with the a value. So what I'm going to do with these two equations is I'm going to add them up. Now, Sn plus Sn would give me 2 times Sn. Equal signs, we don't actually add those up. Now, I lined it up this way for a reason. Here we're going to add up a plus term n. I'm going to put that in brackets like this. So a plus term n is that first column, adding it up. So next I want to add up this column right here. So what we have is a plus d plus term n minus d. So what happens here is if you add d plus negative d, those d's cancel out, and again we're just left with a plus term n. Over here as well, the next column that I have, a plus 2d, and then plus term n minus 2d. Again, 2d will cancel out minus 2d. So what we're doing is we're just adding, again, a plus term n. Now, that is going to continue happening until we get to the very end right here. Our last terms, we're adding, again, a plus term n. So as you can see, we are adding together a plus term n many, many, many times. So the question is, how many times is that? Well, it's going to happen n number of times. Because we're starting at term 1 and then going all the way up to term n, that's n number of times that we're adding things. So I can do a little bit of magic here. So 2 times the sum of the first n terms will be equal to n times a plus term n. So that's a shorter way of writing the addition of n of these. Now I do want a formula just for the sum, so what I can do is I can divide both sides by 2 here, and here we have, this is one equation that we can use, so the sum of the first n terms is equal to n times a plus term n divided by 2. So there's one formula that we can use. Now remember that we also know that because these terms are an arithmetic sequence, we actually have an equation for the nth term. So remember that term n is equal to a plus n minus 1 times d. So if I put that in the place of term n, we can actually get another equation. So the sum of the first n terms be equal to, we got n, and then I'd have a plus this whole equation here. So I would actually have two a's at that point plus n minus 1 times d. And then the whole thing is divided by 2. So this is another equation that can be used in different circumstances. So the two equations that we just made will work in different circumstances. They both will give you the sum of the first n terms, but looking at the question that we have here, we have to determine which one is more appropriate. So we want to find the sum of the first 50 terms of this series right here. So what I can say first, all right, so I want to figure out the sum of the first 50 terms. That means my n value is going to be 50. Now, let's say that I want to use this equation right here. I do know that n is equal to 50, so I have that variable right there. I know that the a value is 3, that's the first term. Now, term n, however, looking at this, I don't know what the last term is. I don't know what term 50 is. So in this case, that formula would not be good. Now, we could actually use an arithmetic sequence in order to come up with that 50th term, but it turns out that we can actually just go straight into this second formula, because what this formula requires, again, n is 50, we got that. The a value is 3, we have that. And what it also requires is the common difference d, and we can tell what the common difference is here. So if we have 3 and then minus 5 and then minus 13. Now you have to look at this a little bit differently sometimes. So a series should always be addition. So what we're doing is we're adding negative 5 and then adding negative 13 and then so on. So what we can see is that the common difference d is negative 8. Alright, so now I'm going to use this formula right here to come up with my sum. So this n value is 50, and then times, we have 2 times a is 2 times 3, plus n minus 1. Now remember, you can write n minus 1, or you can just write down what it is, so it's 49 times d, and then the whole thing is divided by 2. So punch this into your calculator and get an answer. So I get an answer of negative 9,650. Alright, so both of these equations are important to know. You could have used this equation, like I said, if you use the common difference and the first term, a, which is 3, you would be able to figure out what term 50 is, and then you can use that formula. But this formula is easier to use because you bypass that step that I just described.